So we have a new wormy friend that's been propagating through GitHub, ShaiHulud 2.0. I guess we can kind of dive into it. So first, credits. You were the first researcher to find this and launch, kind of announce publicly. So I guess, I don't know, congrats. Kind of feels weird.
Yeah.
Something like that.
Dubious honor.
So let's start with kind of the findings. We're going to get into the inner workings of it. We've learned a lot since kind of we first posted about this, how the whole thing started. But first, let's go through discovery. How did you just discover this? Yeah. What happened that fine Monday morning?
So sat down on my desk, pulled up the triage queue, saw it was quite busy. And I pull up one of the packages and I see it had triggered on our Shai Hulud rules. And I was like, nah, surely this must be a false positive. But it was in a really big file. So I was like, oh no. So I pull through it and like, sure enough, this is a variant of Shai Hulud. And then I look through, right, I start frantically posting like, nope, this is real. I find initially the Zapier packages and I see, I think it was PostHog and then Postman and then the AsyncAPI. I was like, okay, these are really big packages, especially the AsyncAPI one. Those are really big. Just like, yeah, no, this is real. And at that point, I didn't even realize how deep our queue was in terms of actual packages that were in there. And when I started to really realize the impact, like the actual scope, how many packages it was, it's like, yeah, this is big. We also then saw, of course, the GitHub repositories was like 20-some thousand. Yep.
Yeah, because I remember the day when we first looked, it was like 16,000, then 17,000, then 18,000. Like it was like I was kind of freaking out that we were going to get to critical mass and it was just going to basically infect everything. Didn't quite happen, but felt like it was close.
I'm just glad that they don't read Twitter.
All right, let's get into that because you reported a bug to Shai Hulud after the first time, and they didn't see your post.
No, they didn't. Thanks, guys.
What was the bug that you had found originally?
So when they actually worm into a different package, they use just like the normal tar command. And that does not strip out user, group, and timestamp information like the normal npm publish process does. So it's very obvious that it's been modified manually. So we can see that it was not published in a normal sort of pipeline. So that was one of the things we implemented straight after Shai Hulud 1. Just like, hey, like we have, like it's, we do get some detections on it that are not Shai Hulud, but it's very few. So when we see that the metadata and the archive is all over the place, yeah, that's a good indicator.
Yeah. So luckily they didn't read your bug report that you posted. I remember you posted
on our blog as well. Yeah.
Okay, so let's then get into how did this kind of start. So for those that don't know, the general mechanics of this is that it compromises packages mostly on npm, but we did see that it's also moved to Maven and other areas. It finds secrets using TruffleHog once it installs onto a victim's machine, and then posts those secrets double encoded in base 64 in a GitHub repository. That's what we were talking about when we said we found 27,000 of these GitHub repositories. It was 27,000, repos that were there. How did it all kind of start? Do we know who patient 0 was yet?
Yeah, so in terms of the NPM packages, it was AsyncAPI.
Okay.
And there's more to it, actually, right? So this is something we've just started to uncover yesterday, right? So Tuesday, about 24 hours in. And today, really looking at it, what we actually saw was that in the case of AsyncAPI, they, a couple of hours before it seems to be, they compromised their Open VSX extension. and deployed that first before they actually compromised the NPM packages.
Right.
So in terms of like actual public spread, the Open VSX extension was kind of patient zero, but they then started seeding it through a couple of NPM organizations.
Right. So it was actually a malicious VS Code extension that was first. Does it likely then that they would have had some tokens for that Open VSX extension that they were able to manipulate it? Is it likely that they managed to steal the NPM tokens through compromising the VS Code extension, or is it likely that they just had tokens for NPM and Open VSX from AsyncAPI?
So they had credentials for both OpenVSX and NPM through GitHub Actions on AsyncAPI, right? So they used the same type of vulnerability. Well, actually, I think the same vulnerability to both compromise their CLI repository and the extension repository, from what I can tell, right? So they kind of realized that they could go for both targets and spread through multiple vectors.
So could you explain the GitHub Actions thing? How did they steal the credentials from the GitHub Actions process, and how do they compromise that?
Yeah, so this is unfortunately a little bit of a complicated thing, because the way that GitHub Action works is complicated. I think one of the things that we saw in the first attack by this group, right, the singularity attack against NX, what we observed was that they used effectively a vulnerability in one of their GitHub Action setups in a public GitHub repository, where using a little bit of branching magic and using this thing called a pull request target, they are basically able to get their own code to run within the context of a GitHub action with the full environment and credentials of the actual organization, but with the attacker code. It's called a own request, PWN request, by GitHub. And we've seen this being more and more popular lately as people have been becoming more aware of it. GitHub did try and is working on actually limiting the ability for these kind of attacks to happen, but it's still possible. And what we're seeing now, just like 5 minutes before we started recording, got a message from the co-founder at PostHog sending me the postmortem that they have just pushed out. And what we're seeing also is that they confirmed it was through GitHub Actions. It was the case with AsyncAPI, right? It was through GitHub Actions. So yeah, and what we're seeing in terms of the metadata from Postman is that it also definitely looks like it was GitHub Actions that was used to compromise.
Okay, so they use GitHub Actions to basically steal NPM tokens and Open VSX tokens. Got it. How on earth do they do that, though? How are they infecting the Actions workflow? And perhaps you explained it, and I just didn't quite understand.
No, it's complicated. Okay, so here's what happens, right? You have a GitHub action that can run whenever a new pull request is made, as an example. And the way that this works is that depending on the configuration of the action, what it will do is that it will check out the code of the branch of the repository, right, that the user is trying to get merged into some other branch. It will check that out. And then for more complicated GitHub actions, you can have these like support scripts, which lives within the same repository. And if you submit a pull request where you're actually modifying the support script, it will use the support script from your branch, right? So you can basically inject your own code into it, and it will run that code before it's even merged into sort of the main branch. So you have like an arbitrary code execution pathway through this support script, because it uses the environment, right? So the credentials and secrets from the main branch and the GitHub action definition from the main branch, but it uses the support script from your branch that you're trying to get merged into some other branch. So there's a mismatch in terms of like, okay, I'm using secrets from the trusted part, but the support script from the untrusted part.
That is crazy.
Yes.
So, I mean, this feels like a gigantic vulnerability in GitHub Actions because, if I'm understanding it correctly, I can make a pull request on a public repository, and without having to get my pull request approved or merged, it can run arbitrary code that I decide in the GitHub Actions. What?
Yes. Yeah, and this is where it gets interesting because when this was first when this theory came out, people also pointed out that the vulnerability in the case of PostHog was introduced back in September. And if you look at the pull request for it, you actually see that the GitHub CodeQL security scanner alerted them saying, hey, this is really unsafe. So, yeah, it's unfortunate.
Yeah, this is kind of feels like, so basically every public repository that is running GitHub Actions has a giant vulnerability where someone could potentially steal your secrets if they have one of these complex scripts inside their GitHub Actions.
Potentially, right? There's a bunch of conditions that need to be met, right? You need to have the right kind of on pull request target. You need to be using these support scripts and things like that. But yeah, there's of course a lot of conditionals depending on the actual GitHub action, things like that. But it's clear that this is a legitimate concern, right? That this is something that a lot of people should be really concerned about. And I haven't looked enough at it to really understand the scope of the problem. But the fact that they were able to target 3 really big entities like this with such a big reach, right? This is concerning.
The only thing that I can think of, and how I'm thinking about this, and maybe this will help some viewers who are wrapping their heads around. I remember discovering in GitHub Actions, if someone used the pull request title or the commit message inside the GitHub action, so if, for example, if inside your GitHub Actions you wanted to print out the commit message or something, if you made your commit message code, then you could get the GitHub action to run your code. This feels like a very complex version of that.
Yeah. But it's, and that's the thing, right? So what we are also seeing as, I think when the AsyncAPI team started looking into it, they were pointing out like, hey, actually like some months ago, we refactored a lot of our GitHub Actions because they were vulnerable to other things as well. Right, so this whole like, the level of how much trust you put into the data that goes through this GitHub Actions, right? The title of the pull request and things like that, right? They're untrusted data. And if you're not really careful about how it's put into actual like shell commands, right, you can really create some ugly situations. And GitHub Actions are just really complicated.
Yeah. Yeah, okay. Well, okay, so I've wrapped my head around the first part. So Postman, PostHog, Zapier, and AsyncAPI all had their... Well, I guess we don't know for sure of Postman, but PostHog we know, AsyncAPI we know that they stole the credentials through this vulnerable GitHub Actions. Yep. They now have the credentials for some Open VSX thing. In the case of AsyncAPI, they had the credentials for NPM.
Yep.
Let's go through what happens next. They compromise those packages.
Yeah, and those packages now go out, and of course the extension, and then Rampage starts, right? So what we saw last time was that the community spread, it wasn't that intense,
right?
But it took off this time.
Yeah, because last time we were able to determine that most of the packages were seeded from the attackers themselves, as in they had stolen credentials in various ways. Most likely through previous breaches, and now they've now they've seeded a few of them, But as we saw, what's the total number of compromised packages? What was the final number?
I haven't actually kept track of that just because there's been so much stuff going on. I think it's north of 800. It must, it's a large number.
Yeah, north of 800 is kind of what I've been seeing around too. So 800 packages got compromised. So the attackers aren't seeding that manually. They really got, it kind of felt like we were one big one away from it just getting critical mass. Like if something really big had fallen, then it would have been all hell breaking loose. I mean, it kind of was all hell breaking loose too, to some point. So let's explain. Let's go through then. Okay, so what did the actual malware do? So it's in this JavaScript file in npm in cases. What did the malware actually do? I'm a victim. I've just installed the malicious version of AsyncAPI. What does the malware do?
Yeah, so it will do a bunch of things, right? So there's a lot of the similar things that it did last time, which is it will see if you have a npm token in your environment. Mm-hmm. And then it will check if you have any packages that you have published or have published access to. It will then try to spread itself into those, right? So copy itself into them to basically worm, right? So it will spread itself through new packages. Mm-hmm. That's the first thing, which is really bad. The next thing it will do is it will look if you have, it will run TruffleHog, right? It will look for secrets. It will take all your environment variables, collect all those secrets together. It will also look for AWS, Azure, cloud credentials, things like that. And then it will collect that all together. And if you have a GitHub access token in your environment, it will just publish in your GitHub repo in your account with all that data. Now, if you don't have a GitHub access token in your environment, it will go into GitHub and it will search for the ShaiHulud repositories. And it will iterate through all those repositories until it finds a valid access token to publish to. So it's basically crowdsourcing access to GitHub repositories to distribute and exfiltrate yourself through, which is really genius because it means that you always mostly have a exfiltration mechanism unless GitHub does something. Now, here's where it gets really nasty. If the environment does not have an npm token, it does not have a GitHub token, and is not able to find a GitHub token through GitHub search, it will delete all of the user's files in the home directory. It becomes a wiper. And credit to GitLab for really pointing this out. We had noticed there was a wiping function. We hadn't really looked at what this mechanism was really trying to do, other than just they also. Right, in the first attack with Singularity, right, they put a shutdown command in people's bash profiles, which is like, oh, that's annoying. But now going to this a dead man switch where if GitHub was to shut them down, right, just prohibit the publishing and searching of these repositories, it will wipe people's machines.
Damn.
Yeah.
Damn. These attackers feel so vindictive because, you can understand why they're doing it. They're trying to get access into things so that they can ransom and presumably make money or get onto things. But a lot of it just feels vindictive in terms of wiping someone's machine. There's no point of that. There's no benefit for the attackers. And the other thing that, and we talked about this before in the previous attack, is why are they publishing the secrets publicly to GitHub? And one of it is that it's a little bit less suspicious using GitHub as a C2 in terms of automatic detection and things. The other area is that it's kind of widely available, and if this really takes off, you need solid infrastructure. But there's some crazy reports about how many secrets total have been found, but it's going to be a lot. And then what's also going to be kind of terrifying is the secondary attackers. So if I'm a bad guy, even though I'm kind of a grayish guy, I don't even need to be full on black hat. The fact that there is, let's just say that probably more than 100,000 secrets that are publicly available on GitHub that you could just be pulling in, what's about to come next is genuinely terrifying. And I know from experience that these secrets won't all be rotated. A lot of them were. In fact, GitGuardian did have a reporting on that. They found thousands of valid secrets. So some secrets you can't validate, so this isn't a total number. There'll be a lot more, but they found thousands of secrets that were actually valid at the time. So that's kind of terrifying. So we know that there's going to be follow-on breaches from this, from the same actors, certainly, but also from secondary actors.
Yeah. And that's the thing. We haven't really been able to tell, right? A lot of the things that journalists will ask also about the previous attacks were, right, so they've been dumping these credentials now, right? But what have they been using them for? And we don't really know. Right? Yeah. Surely they've used them for something, right? Because they did get a lot of credentials. But we really haven't, at least I haven't seen any reporting anywhere that has really made that connection, right? And now we've got it at a scale that is, I think probably an order of magnitude larger, I would estimate. That is probably one of the big concerns. It's like, what's next?
So it started off. I want to kind of switch back to Open VSX now, because the malicious extension was. I'm wondering, have more VS Code extensions on the Open VSX marketplace been compromised? We've talked a lot about malicious VS Code extensions before in recent times. It seems to be a big a big attack path. Was it just the one that we saw, or have there been multiple that were compromised on this area as well?
Currently, for this attack, we're only aware of this one.
Right.
Yeah.
It's interesting. Because that also, and I wonder if the same mechanisms would have happened for that, as if the self-propagation part could have also happened in VS Code, and maybe that's why we've only seen one. Is that there was no self-propagation; it was just kind of opportunistic. It's like, look, I have this key too. Let's do it. Let's do some stuff with this key.
Yeah.
Yeah.
There's some quite interesting techniques that they are using as a part of the Open VSX part that we are currently investigating, and we're waiting for some answers from some ecosystem partners, because I think there's potentially a little bit of a previously unrealized technique here that is not ideal, that the ecosystem might want to change a little bit. So still to be seen, but there's some novel stuff there going on. Which makes it a little bit harder to reason about what they actually did with that. Right.
Now, the other thing that was kind of interesting is just going through the post-hog post-mortem. Yeah. It really looked like that they were compromised a long time before this all unfolded. Yeah. So what do we know about when post-hog was actually compromised, and does this correlate with other things that you've seen out there?
Yeah, so the reporting that just came out in the last half an hour from post-hog suggests that the initial kind of signal that they could find, right, of this threat actor getting into their systems was on the 18th. That was Tuesday last week. So about 6 days, a little over a week actually. Before, a little under a week. It's been a rough couple of days. Less than a week. Yeah. So they have clearly been probing around, right, and trying to see how much critical mass it can collect, I think. Right, And we don't know if there's other people out there, right, that they're just waiting for the next one. Because if they can find it in these 3-4 organizations, I'm sure there's more.
Yeah. Yeah, exactly. And to be honest, my first thought when I saw this was like, oh, they're using stolen credentials from the previous attack. Yeah. Like didn't rotate their credentials or something like that. Obviously, that's false. It was through the GitHub Actions. Let's talk a little bit about the security features that NPM is rolling out conveniently in about a couple of weeks. Yeah. Would that have, so the main one is that they're expiring long-lived personal access tokens for NPM. Would that have helped in this case, like that? Or because it was kind of like stealing and using tokens immediately, would it have made any difference at all, the new security features on NPM, any of them, or would we still be suffering the same fate?
So I am not 100% sure exactly what the type of token was, right? If it was a legacy token or not. I think it might not have made a difference, to be honest, right? Because these tokens Well, actually no, because they were also going to start to move everything to time-limited tokens to try to push everybody into like trusted publishing and things like that.
Yes.
Of course, it would have made a difference, right? Because everybody would have had to look at their setup again, right? All of the tokens that they're using in different places. So I think it would have made a slight difference. But in this case, because they are getting arbitrary code execution on their GitHub Actions, well, in that case, bets are kind of off in my mind.
Yeah, because then, well, I guess definitely at the first start, because they're kind of getting a brand new, they're getting a brand new token anyway. But what about the self-propagation part? What about stealing like NPM tokens from the developer's environment and then reusing them? Would it have at least stopped that mechanism?
It would likely have reduced the impact for sure. Yeah, I imagine a lot of the community spread was from people with legacy tokens, right? Really long-lived tokens. So yes. I think, I mean, still, all those changes are absolutely beneficial. Yes.
Yeah. But I think what's important to take away is that, like, this problem isn't going away just because we're making some changes. It's great that NPM is doing this. We were advocating it for a long time. Fantastic. May have helped reduce the impact of this. Wouldn't have stopped the initial compromise of the first few big companies. And, So,
well, there's one thing here that's really depressing. So when
lovely, Charlie. I love it when you when you start a sentence with that.
So I was quite a lot in contact with the AsyncAPI team, and they told me that they were 2 days away from shifting over to trusted publishing.
Oh, man.
Yeah, ouch.
Oh, sometimes you just wonder if, like, these people kind of know, right? Yeah.
Yeah. That's bad timing.
Well, here's another thing that's pretty depressing. I just checked on GitHub right now. Now, it looks like GitHub has deleted a lot of these repositories. We've gone from a peak of, I think, around 28,000 repositories down to 350 with the last one coming in 3 minutes ago. So it's still happening. It's still ongoing. We're in day 3 of this, and we haven't made a difference yet.
Well, it also means we're about to hit a point where the wiping mechanism will have triggered.
Right, because I'm wondering, I was looking at this and I was like, well, GitHub are clearly deleting it, but they're not blocking new ones being created with the same name, and I guess part of that is because, they don't, like, GitHub has a lot of power in their hands right now, like, in terms of, like, if they block this, so crikey, what's worse, having all your secrets leaked, or having all your secrets leaked, or getting your computer wiped. I think I'd take the computer wipe, to be honest.
Yeah,
that's a better option.
So the other interesting thing yesterday, what we saw was that somebody had decided to write a script, and they were automatically going through all of the Shai Hulud repos and force pushing, deleting the data in there. So they could actually have accidentally triggered the wiping as well. I think they thought they were doing something good, but actually they could have triggered a situation where the wiper would have activated as well. Whether or not they knew, who knows? But that was going on.
Yeah. This is so crazy. Now, do we have any idea of who the actors are, or if they're state-sponsored? I mean, this probably is getting a little bit speculative, so, if we don't know, we don't know. But is there any indication? Like, are there any indications of, like, what languages the attackers are using? We know they're Dune fans, so, but that's kind of all we know right now, isn't it?
Yeah, I mean, no, we have no clue. I have seen no reporting on it. I mean, the only fun speculation I've seen is that this is somebody who's got a bone to pick with GitHub and NPM, so Microsoft, right? Basically pointing out the shortcomings of the security posture of the whole ecosystem. But again, that is speculation.
Yeah. because like I. The thing I'm still struggling with is what is in it for the attackers. Now, you can look at some obvious things, but there's no big signs of, like, there's no mechanisms in there to try and mine crypto, or there's no mechanisms in there to try and, like, steal cryptocurrency, which is, like, the most obvious indication of what people are trying to do. They're stealing credentials, but they're publishing it, so therefore everyone knows their credentials are public, so they're more likely to rotate them. Like, part of it feels like this is just someone that's trying to make chaos out there. I feel like there's a Batman quote that fits well here. You know, like some people just want to watch the world burn.
Yeah. So what we saw the last 2 times, and we also have seen, I think it was yesterday it started, right? What they've done after like 24 to 48 hours was that suddenly they would also start, for the victims that were compromised, they would start flipping private repositories to public, also from organizations. So I saw yesterday, it was last night, this morning, like Business Insider had a bunch of private repositories turned public.
Right.
And we saw this the last 2 times as well. Again, right, that suggests that the MO, right, what they're really trying to do is that they are trying to compromise deep into systems, trying to get IP such that they can find more ways of getting into companies.
Right.
Or just cause chaos. Who knows?
Yeah, I mean, I can understand that using the GitHub as the C2 and everything, but I still think that if their goal was to really attack companies and everything, I still think there's better options than pushing everything publicly, right? Because it makes a whole lot of noise, you know, and we know exactly who's been compromised. We can reach out to them, it's GitHub can reach out to them and let them know they've been compromised and all of this kind of things. But if it was all being done privately, you know, it'd be much harder to be able to tell. So I kind of I'm just kind of leaning towards I'm sure there's financial benefit in there somewhere, and I'm not going to deny that. But the way that they're doing is like they're choosing to do the most amount of destruction possible.
Yes, and I think it makes sense, to be honest. I think it is a sensible way of doing it, because what they are really relying on is the fog of war. That's what it is. Because so a lot of people are getting compromised by this. Right, a lot of the repos that you see out there with tokens, right, are completely useless. There's going to be some gems in there, right? And the time it's taking for everybody to do triage and shift through everything and figure out, like, what are all of these things? Even realizing that they were impacted to begin with, the time that takes is enough.
Yeah.
Right, because frankly, it's the scope of this is hard to imagine.
Right. Gosh, it's a cheery episode, this one. I hope everyone's feeling really positive and upbeat about it all. I'm trying to think of some funny things to say, but
I think this has been a trend lately. Our episodes have just not been cheery at all.
They haven't been. Charlie.
Yeah. I'll try not to end on a bad note this time, hey?
Do you have a good note?
I really don't.
No. I
No.
don't think so.
Christmas is coming up soon.
Oh, that is nice. What else are we kind of missing about this too? Like, so, is there anything else that we've uncovered since this? So we now know the mechanism of who the first victims were. We now know how they got into those first victims. They kind of exploited a flaw in GitHub Actions, but also a flaw in kind of the scripts that these companies were using. We know the mechanisms and how it worked. Kind of roughly know what they're after.
Yeah.
What else are we kind of missing, and did we learn from this, or have we kind of covered the basis now?
I think what's maybe scary about this is that we only really realize what happened a fair bit after the fact, right? And the avenues that they're kind of using to do this are quite varied, right? So obviously there's the whole GitHub Actions things. We're seeing the whole Open VSX thing as a way of deploying. There's clearly some sophistication behind these people, right? They at least are evil enough geniuses, right, in terms of like the really nasty, like the dead man switch that they're putting into things, that this creates, like, if they are going to take it a step further, I don't want to know what that is, right? And if they are able to do fun things like this, right, what other sleeves of their trick do they have?
Yeah, for sure.
Right. I mean, we've seen like with Open VSX, right, all credit to like, they do respond pretty quickly in my experience, right, and take things down. And they are doing things to like scan things before now. But they have been a soft target lately. There's no question about that.
Yeah, and you can also like understand it. Like the VS Code marketplace is Microsoft. It has big budgets behind it. Open VSX is a marketplace that spun up because of a need with all of these VS Code forks, like Cursor, like Windsurf. And you can almost like, and it's a company, and you know there's profit behind it and stuff. But it still feels pretty community driven. So you can understand why it's a soft target, and it's going to remain a soft target for a while to come, because you can't just overnight harden your entire workflow for it. Maybe you can, but I can't imagine that happening.
And that's the thing here we're seeing, right? So I mean, historically, right, the idea has always been, right, you can protect yourself by just, when a bear is chasing you, run faster than your mate. That doesn't work, right? Not in this kind of situation, right? When the attack can spread exponentially, right? Yeah. And these people have really targeted GitHub, NPM, right? Microsoft overall, right? And I think it's obviously a huge wake-up call for Microsoft, right? They're realizing that the legacy that they have built through the different like dev experience kind of products have really created a technical debt that is now coming to bite us. There's more technical debt out there, right, in these ecosystems where we have gone way too fast in terms of the technology we have built.
It's going to be very interesting. It's going to be very interesting to see what happens in the future. Well, Charlie, you promised to leave on a happy note, so you did that. You achieved it. You depressed everyone. So don't blame us.
Nope.
If you're feeling extra gloomy after listening to this episode.
Yeah. Don't be afraid to reach out to a psychologist.
Well, Charlie, thanks for spending time with me as always. We'll wrap it up there. We were going to do a different episode on a whole different topic, just a few days ago. So I've even forgotten what that was. But we'll be bringing out another episode, hopefully about interesting things. Hopefully the world doesn't crash and burn in between them. But Charlie, thanks for joining here. Thanks for being here, and we'll see you all on the next episode.
See ya.